Hello, everyone. Hello, everyone. Hello, Nifemi. How are you? Hello, Nifemi. How are you?
I'm
Hello, Nifemi. How are you?
fine. I'm fine.
103, 103. Yes, now. 43, 50, and then 10,000. All of them 103. You're welcome to today's class. How are you today?
I'm fine.
Beautiful. Today we're going to be treating ionic bonding. Are you ready for what we have in today's class?
Yes,
All right, beautiful. Can you see what's on the screen right now?
yes.
All right, beautiful. So we're going to be talking about ionic bonding. We've been building from a foundation since the beginning of these free chemistry classes. We started with atomic structure and periodic classification. So we're moving on to something that we can build on, which is ionic bonding. So at the end of today's class, there are some things that I want you to be able to do. They are our learning points and the objectives that I want you to be able to achieve at the end of today's class. Can you still hear me clearly? Can you hear me
Yes,
clearly?
sir.
All right, beautiful.
Yes, sir.
So, the first thing that I want you to be able to do at the end of today's class is I want you to be able to state which types of elements ionic bonds can exist between. And then next, I want you to be able to describe what happens to electrons when an ionic bond is formed. And then I want you to be able to explain some key properties of ionic compounds. So without wasting time, let's get into what we have for today's class. So on the screen right now, you can see some explanations. We have the explanations for elements, we have the explanations for metals, and we have the explanations for non-metals. So we're going to start off by defining what ionic bond is. So I'm going to be writing them out, and I hope you're with your notepads, your notebooks, and your pens. Is that correct?
Yes, sir.
Yes,
All right, beautiful. Hello, you're also welcome to today's class. I'm so happy to have each and every one of you around. So let's write ionic bond. Ionic bond is a type of bond, a type of bond that is formed between metals and non-metals. Can you see what's on the screen right now?
Yes,
yes,
sir.
Good. I'm going to be giving you two definitions. So this is definition number one. Okay. And then this is definition number two. So the second definition, before I give that to you, I want to explain something. Before an element can undergo a reaction in most cases, it either loses or it gains electrons. Are you with me?
Yes, sir.
Good. Before an element can undergo a chemical reaction, it either loses or gains electrons. Now, watch this. Whenever an element loses an electron, it becomes positively charged. Are you there?
Sir.
Good. And whenever an element gains an electron, it becomes, do you want to guess?
Negative. negative charge.
Thank you
Nature's.
very much. It becomes negatively charged. So, an ionic bond is simply a bond that is formed between positively charged ions and negatively charged ions. Now, watch this. Remember, we started off by defining an ionic bond as a type of bond that is formed between metals and non-metals. Are you with me?
Yes.
Good. Now, here is the special characteristic about metals. Metals love to give or they love to lose electrons, while non-metals, they love to take or they love to gain electrons. Did you see what I just wrote?
Yes.
I hope you're writing too.
Yes.
Beautiful. So metals love to give and lose electrons, and non-metals like to take or gain electrons. So when metals give or when they lose electrons, they become positively charged. And positively charged ions are called, see the word, cation ions. And then when non-metals take or when they gain electrons, they become negatively charged. And what is the name that we give to ions that are negatively charged? Do you want to guess?
Anion.
Thank you very much. We call them anions. Anions. So that brings us back to our definition that we were talking about from the beginning. So ionic bonds forms between metals and non-metals. Can you see the first statement?
Yes.
Good. Can you give me an example of a metal that you know?
Hydrogen.
Hydrogen. Beautiful. No, no, hydrogen is not a metal. No, no, no. You can't classify hydrogen as a metal. Give me another example.
So- Sodium.
Sodium. Thank you very much. Sodium. That is Na. How about you? What other example of metals do you want to give to me? What other example do you know?
Calcium.
Magnesium.
Magnesium. Magnesium. Beautiful. Magnesium. Can you tell me the symbol for magnesium? Mg. So
Mg.
good. Basically, the elements that ionic bonds can be formed between are metals and non-metals. So what are metals? Metals are elements that can be found in the middle and on the left-hand side of the periodic table. Non-metals can be found on the right-hand side of the periodic table. Thus far, so good. So far, so good. Do you have any questions to ask? Does anybody have a question to ask?
No, sir.
All right, beautiful. So now I want somebody to read for me. Dorcas, I want you to read for me what you can see on the screen. There is a definition there that shows what ionic bonds are. Can you read that for me?
An ionic bond is formed when a
Mm-hmm.
metal and non-metal react.
Good.
Metal atoms become positively charged ions by losing electrons.
Now hold on.
Non
Hold on. Do you remember from the example that I gave you or from the previous slide, I told you that metals, they love to give or lose electrons. Do you remember that?
Yes, sir.
Good. And when they lose electrons, what happens?
The non-metals receive the electrons.
Good. The non-metals receive the electrons and then they themselves, they become positively charged.
Positively charged.
Good. And positively charged ions are called what?
Cations.
Good. So let's proceed now. Non-metals, on the other hand, become negatively charged ions by gaining electrons. So the oppositely charged ions are very strongly attracted to each other. This is known as electrostatic attraction. So the force of attraction that occurs between ions whenever an ionic bond is being formed is called electrostatic attraction. Can you repeat that after me? Electrostatic attraction. Can you repeat that after me? Electrostatic.
Electrostatic attraction.
Good. Beautiful. So now I want to show you an example of how metals and non-metals react in an ionic bond. Would you like to see that?
Yes, sir.
All right, good. So first things first, you remember I showed you how to draw the electronic configuration of elements on the periodic table in our previous class. Is that correct?
Yes, sir.
Good. So now let's take, for example, a metal. And that metal is called, what is the name of this metal that I just drew the symbol for?
Sodium.
Thank you very much. Sodium. And let's say I take another element that is a non-metal. And let's call this guy Cl. What is the name of this guy?
Chlorine.
Thank you very much. Chlorine. Now watch this. Whenever sodium and chlorine want to react together, this is how the bond is usually formed. First of all, let's draw the structure for sodium. We have Na. The atomic number for sodium is 11. In other words, it has 11 electrons. So let me draw what the structure looks like. On the first shell, you have 2 electrons. Can you guys see what I'm doing?
Yes, sir.
Good. Then on the second shell, we have 1, 2, 3, 4, 5, 6, 7, 8 electrons. How many more electrons do we have to draw now?
2.
Are you sure?
1. No.
1
1.
to make up 11. And then we have chlorine over here, Cl. Chlorine has the atomic number of 17. So this is the first shell having 2 electrons, 1, 2. And then the second shell having 1, 2, 3, 4, 5, 6, 7, and 8. 8 electrons. How many more electrons do I have to draw?
7.
7 electrons. Thank you very much, because we have 17 electrons and I've drawn 10. So 1, 2, 3, 4, 5, 6, and 7. So now, do you know what happens? Which of them is the metal between the two of them? Sodium and chlorine. Which one is the metal?
Sodium.
Good. So which one will lose electrons? Which one will lose the electron?
Sodium.
Thank you very much. So this one electron over here, sodium will say, chlorine, are you sure you will not take this, my one electron? I don't really need it anymore. So the one electron will now go. And then chlorine will say, yes, 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 bring it. I'm in need of electrons. That one electron now leaves sodium and comes to chlorine. Now, do you know what will now happen? Sodium now becomes positively charged. And since chlorine has received the electron from sodium, chlorine now becomes negatively charged. Now, because the two of them are oppositely charged, they will now be attracted to each other. This one will be attracted to this one. Chlorine and sodium will now be attracted to each other. So therefore, they will now join together and we have sodium chloride. Did you see what I just did?
Yes, sir.
Is it confusing?
No, sir.
We're going to treat more examples as we proceed, okay? So now, look at this. On the left-hand side of the screen, you can see this over here, forming of positive ions. Metal atoms lose electrons to form positively charged ions with a full outer shell of electrons. Are you all with me?
Yes.
All right, beautiful. Now, let me show you something. The reason why atoms gain or lose electrons is because they want to be stable by having a full outermost shell. Can you all read what's on the screen right now?
Yes.
All right, go ahead and read it.
Reason why atoms gain or lose
They want to
electrons. Full atom.
Very good. Very, very good. Now, how do we know if a shell is fully filled, or how do we know that a shell is now full? Now, here is how you know. Remember, I taught you in the previous class that in order to know how many electrons that a shell can occupy, you use the formula 2n squared. Do you remember this formula? Who remembers it? Who remembers this formula? Yes, Nifemi, you want to say something? I see you raising your hand.
I still do remember this.
Okay, you remember, do you remember it?
Yes.
Beautiful. So for instance, now let's say we have shell number one. For those of you who do not remember, this formula simply tells us the number of electrons that a shell can accommodate. So if we have shell number one, it means the number of electrons that can stay will be 2 multiplied by 1 because n stands for the number of the shell. And in this case, that's number one. 1 raised to the power of 2. This will be equal to 2. So the number of shells that can stay in an electron is given by 2n raised to power 2. So if an atom has only one shell, it means it can accommodate only 2 electrons. So for instance now, look at this element on the other side of the screen. Let me move a bit. Who can see this element that I'm labeling right now? Okay, beautiful. What is the name of the element?
Lithium.
Thank you very much. Lithium. Very good. Lithium. Good. Very good. Lithium. So now look at this. Lithium has an outermost shell and it is a metal. An outermost shell having only one electron. Can you all see that? And then it has two shells. Shell number one over here and shell number two over here. The first shell has 2 electrons and the second shell has only 1 electron. So for lithium to become stable, this 1 electron will have to go so that it will be left with only 1 shell. And remember, if an element has just 1 shell, the number of electrons that it can occupy are 2 electrons. So that is why it is now having two electrons over here because it is just one shell. Do you understand?
Yes, sir.
Are you sure you do?
Yes, sir.
Beautiful. So that one electron that it has lost, look at fluorine over here. Fluorine has 7 electrons in its outermost shell. And how many shells does it have? It has 2 shells. So if we want to know the number of electrons that it can occupy, we use the formula 2n raised to the power of 2. So that will be 2 times 2 raised to the power of 2. That gives us 8. So it can occupy 8 electrons, but it is having 7 electrons over here. So what will now happen? It will now take that 1 electron that lithium has lost over here. So that 1 electron now travels all the way to fluorine over here, and then fluorine now gains it and becomes negatively charged. That is why you have a minus sign over here. Did you all see that?
Yes, sir.
Beautiful. So when that happens, fluorine becomes negatively charged and lithium becomes positively charged. And then the element or the compound combining fluorine and lithium will now be formed. So let's move to another example right now. Does anybody have a question? Does
No,
anybody
sir.
have a question?
No, sir.
All right, all right. In the absence of any question, here are some handy tips for you. For elements that are in group 1, group 2, and group 3, the number of electrons that are lost is the same as the group number. I'll take that one more time. For elements that are in group 1, group 2, and group 3, the number of electrons that are lost is the same as the group number. So for instance, what they mean is this. If I have an element in group 1 and it is a metal, the number of electrons it will lose is 1 electron. If I have an element in group 2 and it is a metal, the number of electrons it will lose are 2 electrons. And then if I have an element in group 3 and it is a metal, the number of electrons it will lose are 3 electrons. Do you understand that?
Yes, sir.
I hope you are writing too.
Yes, sir.
Yes, sir.
Yes,
Good.
sir.
Now, for elements that are in group 6 and group 7, the number of electrons gained is 8. So subtract the group number. For example, oxygen is in group 6 and it forms a 2 minus ion. Here is what we mean. If an element is in group 6, for instance, the number of electrons that it will gain must make it to complete to 8. If an element is in group 7, for instance, the number of electrons that it must gain must make it to complete to 8. So for instance, look at this example, chlorine. Chlorine has this structure, Cl, shell number 1 with 2 electrons, shell number 2 with 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. And then shell number 3 with 7 electrons. 1, 2, 3, 4, 5, 6, 7. Now, chlorine is in group 7 on the periodic table. I want to ask the question, how many more electrons is it going to gain?
1.
Thank you very much. Why is it 1?
Because is one it needs one electron to be eight. To be
Thank you
eight
very
electrons in
much. It
blue.
needs one more electron in order to be 8 electrons completely, and it is in group 7. The same thing for oxygen. Oxygen has, let me write the symbol for oxygen and draw the structure for you. So this is oxygen, shell number 1, 2 electrons, 1, 2, and then shell number 2, 6 electrons, 1, 2, 3, 4, 5, 6. Now, oxygen is in group 6 on the periodic table. How many electrons will it gain? Yes, who is answering my question? How many electrons will it gain?
Two electrons,
Thank you very much. Why is it 2 electrons?
because it needs two electrons to become eight.
Thank you very much. It needs 2 more electrons to add to the 6 that it has in its outermost shell in order to become 8. That is what we're saying in this page. Thank you very much. I'm super excited that you are following with this lesson. Now look at this. Sodium and chlorine. Sodium is in group 1 and chlorine is in group 7. So I want to ask the question, which one is going to lose an electron and which one is going to gain an electron? Who is answering my question?
Sodium will lose an electron.
Thank you very much, because sodium is the metal. Which one is going to gain the electron?
Chlorine.
Thank you very much. Now, my next question is this. Sodium is in group 1 on the periodic table. Chlorine is in group 7 on the periodic table. How many electrons will sodium lose? And how many electrons will chlorine gain? Who is answering my question now? How many electrons will sodium lose? And how many electrons will chlorine gain? Who is answering my question now? If sodium is in group 1 and chlorine is in group 7. Yes.
Sodium will lose one electron, while chlorine
Okay.
will gain one electron.
Okay, you are correct. But do you know why sodium will lose just 1 electron? Yes, who wants to explain to me why sodium will lose 1 electron? Okay, since nobody is
So it will
explaining,
have a stable electronic configuration.
good. So it will
So
have a
it will
stable
have a stable.
electronic configuration. That is beautiful. Now, by stable, we mean it now has 8 electrons in its outermost shell. Now, watch this. This 1 electron, if it loses it, this is what the structure will now become. And if you look very well, the number of electrons that are present in the outermost shell, let's count it. 1, 2, 3, 4, 5, 6, 7, 8. So you can all see that it is now stable because it has 8 electrons in its outermost shell. The same thing for chlorine over here. Chlorine gained 1 electron from sodium. After gaining 1 electron, let's see what the configuration for chlorine will now become. How many electrons does it have in its outermost shell? 1, 2, 3, 4, 5, 6, 7, and 8. So you can see chlorine is now stable because it has gained 1 electron. And because it has gained it, it is now negatively charged. Do you all understand what's happening here?
Yes, sir.
All right, beautiful. Now, my next question is, which one is the cation and which one is the anion? I want somebody who has not spoken before to speak now. Bukumi, I want you to speak. Which one is the cation and which one is the anion? Yes, Bukumi. Which one is the cation and which one is the anion? If Bukumi is not speaking, somebody else can speak. I want you to tell me which one is the cation and which one is the anion.
Sodium is the cation
Mm-hmm.
and chlorine is the anion.
Okay, why is sodium the cation and why is chlorine the anion?
Because sodium is giving an electron to chlorine
Okay, and then why is chlorine the anion?
because it's gaining electron.
Thank you very much. And remember, we said when an element gives away electrons, it becomes positively charged. And positively charged ions are called cations. And we also said that when an element gains electron or receives electron, it becomes negatively charged. And negatively charged ions are called anions. Beautiful, beautiful. Thank you very much. So now the next example that we have are two elements, lithium and oxygen. So now the first question I want to ask, which one is the metal and which one is the non-metal? Who is answering my question? Which one is the metal and which one is the non-metal?
Lithium is the metal, while oxygen is the non-metal.
All right, thank you very much. So lithium here, let's label it. It is the metal. And then oxygen over here is the non-metal. So now the next question I want to ask is this. Lithium is in group 1 on the periodic table, and then oxygen is in group 6 on the periodic table. Which one is going to lose an electron and which one is going to gain an electron? Yes, who is answering my question? Which one is going to lose an electron and which one is going to gain an electron?
Lithium loses an electron
Okay. And then oxygen
while
gains.
oxygen electron.
Beautiful. Now, my next question is, how many electrons are lithium going to lose? Or is lithium going to lose? How many electrons? Since lithium is in group 1, how many electrons is it going to lose?
One
Thank you.
electron.
Thank you very much. Lithium is going to lose 1 electron. Now, oxygen, on the other hand, needs to gain 2 electrons in order to be complete to 8. Is that correct?
Yes, sir.
Good. So now, since lithium can only lose 1 electron and oxygen needs to gain 2 electrons in order to be complete to 8, what will now happen? It means therefore that lithium will now use 2 atoms of lithium in the reaction because every atom of lithium can only donate 1 electron. So therefore, it means that oxygen that needs 2 electrons, 2 lithium atoms will now come and say, okay, I will donate 1 electron to you, oxygen. And then the second lithium atom says, I will donate 1 electron to you, oxygen. That way, oxygen will now be complete with 8 outermost electrons. Did you all see what happened?
Yeah.
Does anybody have any questions to ask at this point?
No, sir.
All right, beautiful. So that is why you have this big number 2 over here. It is simply telling you that 2 atoms of lithium were used in the reaction. So that is why when lithium and oxygen react together to form lithium oxide, the chemical formula is Li2O. So now let's proceed to the next example before we call it a day. Here are some characteristics of um, ionic compounds. Characteristic number one is called conduction. So can somebody read for me what is on the screen right now? Yes, who is reading for me what's on the screen? I want somebody to read for me what's on the screen. First characteristic of ionic compounds.
Conduction.
Okay.
Conduction.
Yes, go
Ionic
ahead.
compounds can conduct electricity. Ionic compounds can conduct electricity when
Mm-hmm.
they are either melted or dissolved in water to form an aqueous solution. In this
Good.
state, the ions are free to move from place to place. Ionic compounds cannot conduct electricity when solid as their ions are in fixed positions.
Beautiful. So what we simply mean is that any ionic compound that you have, it can conduct electricity when they are either melted or when they are dissolved in water. A very good example is sodium chloride. A very good example of an ionic compound is sodium chloride. This is the metal, sodium, and this is the non-metal, chlorine. And this is also known as your normal table salt. So what we are simply saying is that when you melt sodium chloride or salt, or when you dissolve it in water, it can conduct electricity. However, when it is solid, it cannot conduct electricity because the ions are in fixed positions. Characteristic number two of ionic compounds are the melting and boiling points. I want somebody else to read for me what they can see on the screen.
Ionic compound consists of oppositely charged ions held together by strong electrostatic attraction. A lot
Good.
of energy is required to overcome this transaction, hence the high melting and boiling.
Good. Remember, we started by saying that ionic bonds are the bonds that are formed between metals and non-metals. So what usually happens is the metals lose electrons to become cations, and then the non-metals lose electrons to become anions. So these cations and anions are oppositely charged. In other words, they will be so strongly attached to each other. And those forces that hold them together are called electrostatic attractions. So in order to overcome this energy that holds them together, that energy must be very high. So that is why they have high melting and boiling points. So if somebody asks you and says, why do ionic compounds have high melting and boiling points? You simply say because of the strong electrostatic attraction between the ions in an ionic compound. Are you all with me?
Yes, sir.
Beautiful. So in today's class, we have come to the end of everything that we've been talking about since the commencement of today's class. We've talked about what the ionic bond is. We've talked about the elements that it can occur between, and we've also talked about the characteristics of ionic compounds. So here are some assignments that I want you to go and do at home. Are you sure you help me do them?
Yes, sir.
All right.
Yes,
Assignment number one. Can somebody read for me what I just wrote?
define ionic bond in your own words.
Okay, beautiful. I hope you can all see what I'm writing.
Yes, sir.
Okay, good.
Sir.
Final question. So these are the assignment questions for today's class. I want you to go ahead, do justice to them, and then send them to me on WhatsApp. Access them, okay?
Okay, sir.
Beautiful. So it's been a pleasure teaching you chemistry for today's class where we looked at ionic bonding. I look forward to seeing your responses to the assignments that I've given today. And up until our next class, which is holding on Friday, stay safe and I'll see you in the next class. Bye for now.
Bye, sir. Thank you, sir.
My pleasure.
Bye. Thank you, sir.